Okay, so our next topic would be mechanical electrical system analogy. So that means we can convert mechanical systems into electrical corresponding system. So in mechanical system, we have the force and torque as our input, whereas in electrical, we can either have voltage or current. So force can be um, represented as electrical system with voltage input or current input. Same as with torque with the rotational mechanical system, it can also be represented as voltage or current input. Okay, so both force translational and torque rotational mechanical systems can be represented as voltage or current sources. Okay, so first let's have force voltage. So for force voltage, we have force as our input in the mechanical system, and the output would be velocity. Kapag naman sa electrical system, ang input niyan is voltage source, we can represent it as small letter E, and then the output would be the current in the element. Okay? So for mass, so these are the three components in translational mechanical system. For mass, this is the representation. So F or force will be equal to mass times second derivative of the displacement over time. So it can be represented as m dv over dt. So paano nangyari yan? It's because derivative of dx over dt squared. Okay? So hiniwalay lang natin tong dx over dt. Okay? Ano ba yung dx over dt? Diba? Yan ang formula for velocity. Change in displacement over time. So, kapag sinubstitute natin yan dito, it will be d, kunin natin to, v over dt. That's why we came up with that formula. Okay. Next, sa electrical system naman, since we said that we will have voltage source, that will be the input, ang representation niyan is an inductor. Okay? So, ang mass equal to inductor. Okay? So, it's because the formula would be E is equal to L di over dt. So, pareho silang first order. Okay? Sa dashpot or our damper, this is again the representation. We have B. And then, formula for it is F or force, this force, is equal to B time, the friction times dx over dt, which is the displacement over time. Change in displacement over time. So again, dx over dt is equal to v. So the formula will be F is equal to BV. Okay? So this is again from the formula of translational mechanical system. And the electrical corresponding for this one is a resistor. So the formula will be I times R. So yung R is equal to B. I mean, corresponding siya sa R. Okay? So BR ML. So since output natin dito is velocity, ang output natin dito is current. So, babalik tayo dito sa statement na to. Okay, next is our spring. So, the formula for spring, right, is elasticity times the displacement. So, for us to have dt in the equation, we will get the integral of the first derivative of time. Okay? Para lang mai-represent natin siya in terms of v. So, that's the goal actually. The why we derive these formulas, kahit alam naman natin itong formula na to. It's because we need to get the v o velocity within the equation. Okay? So, pag kinancel mo to, so, Ano ba? Ganito. So, V, again, is equal to dx over dt, right? So, dx over dt times dt, ito, nandito, yan, kinopya lang natin, is equal to dx. Dx, integral of that will be x. So, matitira pa din is x. So, I just wanted to explain na equal lang tong formula na to dito sa derivation. Okay? So, what about in electrical system? Ang katumbas naman ng spring is capacitance, capacitor. Okay? So, gagayahin natin tong format nito, wherein we will have the integral formula. So, the integral of current times dt. Okay? So, that will be the formula 1 over c integral of I dt. Okay? So, M will be L, B will be R, K will be C. Okay, so ito lang yung tatandaan. Ito is may D, ito ay wala, ito ay integral. So, just shortcuts for you to easily remember. You can have your own mnemonic for this as well. Alright, so important notes. In converting mechanical system to electrical system, you should remember the following rules. So, mechanical system has same velocity if it's series. Okay? And, kapag naman sa electrical system, same sila ng current kapag series. That's why the output is velocity and current. So, for mechanical system, the node or mass, so, diba kino-consider natin ng bawat isang mass ay node, is same as a closed loop in electrical system. So, ang isang mass daw, sabi, isang mass yan, is equal to a loop in a closed loop in electrical system. Inductor. Okay. Next. The number of masses then in mechanical system will be equal to the number of closed loop or meshes in electrical system. So, sabi, isang mass is equal to one closed loop. So, kung ilan yung number of masses, yun yung number of closed loops ng electrical system. Then, element between two masses in mechanical system will be element between the meshes in electrical system. So, let's have an example to better understand this. So, mechanical system conversion to electrical system. So, again, I have this mnemonic here. So, ML, BR, KC. So, this is the example of mechanical system. So, we have two masses or two nodes in the mechanical system. So, we will have two meshes here or two loops. Okay? So, each loop, syempre, meron siyang one current. So, ito naman is principle to ng electrical system. Okay? So, isang loop is has the same current and different voltages in each element. So, we call that voltage drops. So, sabi, elements between two masses is equal to the element between meshes. So, for example, here we have F1. Sabi natin pag force voltage conversion, ang force is our input, whereas in electrical system, the input would be E, voltage. So, force voltage. Okay? And then, so, ano ang connected sa ating M1? Ano bang mga connected sa M1 natin? We have this B here due to friction. And then, we have B1, damper. We have the spring K1. But, this K1 and B1 is they are both between M1 and M2. So, yung K1, ano ba yung katumbas ng K? C. So, lalagay tayo ng C1 dito. So, it's between meshes 1 and meshes 2. Then, yung B1, ang katumbas ng B is R. So, we need to put resistor 1 here. Okay? So, paano naman itong nandito? So, yung M, ko-convert natin siya sa L. So, we will have a series L1 here. And then, for the friction, since hindi naman siya connected sa M2, sa M1 lang siya connected, then we will have it here, resistor R. So, for convention, since M1 to, L1, B, R, kung ano na lang yung ginamit na subscript dito sa mga elements ng mechanical system, that's what you're going to put as well in the electrical system. So, B1, that will be R1, K1 will be C1. Okay? And then, for M2 naman, so, okay na tayo sa K1, B1 kasi connected na rin yan sa loop 2. Okay? Wala tayong extra friction here because we put some wheels. So, ang connected sa kanya is K2 and B2. Ano ba yung K? Again, K, C. K, C, C2. So, K2 subscript 2. So, C subscript 2. And then, don't forget as well the inductor, L2. That's, ang katumbas ng M2 natin dito. Ano pa? K. And then, B. Yung B will be R2. Okay, so this will be the corresponding electrical system. Understood? So, again, yung force naman, again, translational system to. We will convert it to current electrical system. Meaning, force ang input and then current ang input. So, we have the current source. And then, output is same velocity. But, the output in electrical system will be voltage in the element. Okay? So, this formula is just the same as in the first one. We just derive the formula so that it will have the variable velocity. Okay? So, ito naman yung itsura kapag current source. Kanina letter E. Ngayon naman pag current, itong arrow. Okay? So, this is standard sa electrical systems. So, current, ang katumbas ng mass, hindi na inductor. Kanina inductor. Okay? So, ngayon, ang current naman na katumbas niya is C, capacitor, capacitance, times dE over dt. Okay, so actually, we can still derive actually this formula from here. But, from here pala, ito yung C. Let's try to derive. So, E is equal to 1 over C I dt. Ano yung formula? DET. So, if we will multiply both sides, so CE is equal to I dt. Okay. CE is equal to I dt. Then, ang papalabasin natin dito is, ano ba yung katumbas ng I? I is equal to, change in voltage. Yan yung formula ng current I. V is equal to IC. 1 over Z, which is C. 1 over C. Okay, so C dV is over dt is equal to, diba VIR? Ang capacitor, it works sa paiba-ibang voltage. Okay, so gawin lang natin ito para standard tayo with this. So, I 1 over C, and yung Z diba Z is equal to I 1 over C. Okay? So, here. So, kung ililipat natin to dito, nagiging C, derivative of voltage over I dt, magiging I na lang to. Okay? So, I is equal to C dE over dt. So, diba, ang ginagawa natin is pinaparehas natin yung format doon sa mechanical system. Yung format meaning kung first derivative ba siya, kung integral, kung wala siyang derivative or integral. Okay. So, again, for mass, we have capacitance. So, I is equal to C dE over dt. Next, for dashpot naman, same pa din, hindi nagbago, resistance. Okay? I is equal to E over R. So, again, this is from the formula V is equal to IR, wherein V is E. So, E is equal to IR. Pag over R natin pareho, I is equal to E over R. So, review lang to ng electrical systems concepts nyo. Next, we have the spring. So, sa spring, same formula. Kapag naman sa electrical system, 1 over L integral of E dt. So, kung papansin nyo, nagkapalit yung mass and spring. Okay? Kasi, ang inductance is actually a function of changing current. Kapag naman yung capacitance, changing voltage. Okay? Alright? So, important notes. So, for mechanical system with the same force, it will be parallel. For electrical system with the same voltage, it will be parallel. So, kasi force is our input, and then voltage is our output here, right? So, it will be parallel. So, for, again, kung ilan yung node, yun din yung number of nodes sa electrical system. Number of nodes sa mechanical system, hindi number of nodes sa electrical system. So, sabi, element between two nodes in mechanical system will be element between nodes in electrical system. So, let's have an example kung anong pinagkaiba. Okay. So, ito naman yung mnemonic ko kanina, MLBRKC. Ngayon, MCBRKL. Okay. Actually, tinatandaan ko lang is yung force voltage. Tapos, alam ko na magkabaliktad yung M and K pagdating sa force current. Para hindi ko na i-memorize tong additional na to. Okay, so, this is the same system, I guess, nung kanina. So, we have two masses. So, we have two nodes here. Ito yung nodes, diba? Kapag sa parallel system, kung ilan yung connection. Okay? So, M1, again, let's start with F, force. We have current here as our input. And then M1, this will be node 1. Ano yung connected sa kanya? So, first, we will have, don't forget the M1. So, ang katumbas ng M is C. So, we have one strand here, C1. Again, I use the same subscript. So, M1, subscript 1 yan. Ang capacitor will be C, subscript 1. And then, ano pa yung connected sa kanya? Itong B. Okay? So, we have one strand here, R. Wala siyang subscript. And then, itong K1 and B1, they are both connected to M1, M2. So, how will we do that? So, we will put it here. So, kung mapapansin nyo, connection nito, connected siya sa V1, connected din siya sa V2. So, ano sila? So, K1 will be L1, B1 will be R1. And then, so, nasa second node na tayo. Don't forget, what's corresponding to M2 is C2. Okay? So, C2. Then, K2, sa kanya lang naman siya, sa M2 lang siya connected. So, we will make sure na connected siya sa V2. Okay? Sabi, force, ang output natin is voltage. Okay? Meaning, pare-pareho ng voltages ang dumadaan dito sa parallel components. So, saan na tayo? K2. Anong katumbas ng K? L. So, we have L2 here. Then, B2, we have R2. So, that's how you convert mechanical system with input force to current system. Okay? Next, let's go to the rotational mechanical system. So, this is just the same concept. Torque voltage muna. So, sa torque, sa mechanical system, input is torque, output is, sa halip na velocity, this time it will be angular velocity. So, again, pagka torque voltage, input would be voltage source, tapos ang output would be the current in the element. So, this is the same as sa force. Ganyan din ang derivation. Ito yung normal formula na alam natin. And then, we had to make sure that the formula will have the variable angular displacement. Okay, it can be theta or this one. Then, same din dito. So, E, ang mass, ang katumbas niya is L, then di dt. Sa dashpot naman, E, katumbas niya ay IR. So, BR. Then, spring will be 1 over C. So, capacitance. Okay? So, same concept din dito sa conversion, actual conversion. So, we have J1, J2. Therefore, we will have 2 loops here. So, our input is theta. Torque. The displacement here is theta. So, our input would be voltage source. Okay? Voltage source. Isa ring, kung ayaw nyo gumamit ng ganito, you can also use this. Kapag naman current, ganyan. Okay? Then, ano-ano ba? Yung J will be equivalent to L. So, L1. J1, L1. Ano pa yung connected lang sa J1? B. B1. Okay? So, we have R1. Sa kanya lang kasi connected. And then, sa gitna ng loop 1 and loop 2, we have this K1. Okay? K1, katumbas ng K is C. C1, right? And then, wala nang connected sa kanilang dalawa. So, let's move on to the second loop. Second loop, J2. Ang katumbas ng J is L. So, L2. What else? B2. So, katumbas ng B is R2. Then, K2. So, kahit pagkapalit, okay naman. K2 will be C2. So, this will be our system. Pero, in this case, dapat ang voltage output natin will be C2. Kasi K2, nandito yung output. Okay? So, how do we write equation from electrical systems? So, para masulat natin yung transfer function or ODE of mechanical system to electrical system, wala siyang direct conversion kung hindi kailangan muna natin kuhanin ang corresponding niyang elements. So, how do we write the equations? So, first, let's look at this loop. This is a torque voltage, right? So, ang E with respect to T or voltage with respect to T is equal to ano yung voltage drops ng nasa loop na to. So, L1 di over dt, di1 over dt. So, ano yung I1? Ito yung loop, yung current dito sa loop na to. Then, I2 will be yung current sa loop na to. So, di over dt, saan galing to? Doon sa formula kanina. Ito. Ayan. So, L1 di1 over dt plus, next, R1. So, I1, R1. Then, same pa din. Dito pa rin galing yung formula. Then, ano pa? Itong C1. Plus, so ito yung formula, 1 over C1 integral of I1 minus I2 dt. So, bakit may I1 minus I2? Dahil dalawa yung forces or dalawa yung current na dinaanan. So, ang direction ng itong I1 and then I2. So, positive, negative. Tapos, pag ganun siya, so positive, negative. That's why, negative ang lalabasan ng I2. So, I1 plus I2. Next, itong second loop. 0. So, wala naman tayong sources dito. Wala tayong voltage source. Is equal to L2 di2 di subscript 2 over dt. Ang C2 ay ito muna R2 plus I2 R2 kasi makipapansin nyo puro I2 yan dahil second loop na tayo. Then 1 itong C2 plus 1 over C2 integral of I2 dt, dahil sa I2 lang naman ang dadaan sa kanya, plus 1 over C1 integral of I2 minus I1 dt. Okay, so ganun siya sa electrical system. Next, kasi ang papasukan niya is positive I2, then minus naman siya sa I1. Okay? So, torque current. Kanina kasi torque voltage. Ngayon naman, ang input natin sa system is current. So, same lang, torque, angular velocity. Ito lang pinagkaiba, current source, voltage in element. So, same formula here. But, ang magkakapalit din, just like dun sa force current and force voltage, ang mass, ang katumbas niya na is C, dE over dt. Dito naman sa spring, yung K, magiging 1 over L. Okay? So, example, same concept. Dalawang masses. So, we have two nodes. So, each node will have E1 and E2, meaning voltage 1, voltage 2. Okay? So, we have this torque, which is equivalent to current source. Okay? And then, J1, J will be equal to C. So, C1. And then, we have B1. So, meron tayong nakaparallel din na R1. And then, that's it for J1. But before we proceed with J2, we have to consider something in between the two nodes. So, ito yung node 1. Ito yung node 1. Ito yung node 2. Right? So, in between them, we have to include K. K1. So, ano ba yung katumbas ng K kapag torque current? L. So, we have L1 here. And then, we can move on to J2. Ang katumbas ng J again, C2. Ang katumbas ng B2, R2. And then, K2 will be another inductor, L2. Okay, so let's get the equation of the converted electrical system. So, for the equation, we have this time current source, so IT with respect to time, is equal to C1 dE1 over dt. So, this is very important to indicate the subscript para alam kung anong current or voltage node or loop panggagaling. So, this is this one, okay? Yung E1. So, ang dadaanan ng E1 will be C1, R1, and a part of this L1. Kasi sila ang connected dito sa node na to. Plus, R1. So, tapos na tayo dito. Next naman, R1. E1 over R1. Plus, 1 over L1. Dahil ito ay nakakonect din sa E1 or sa node 1. But, this time, we have to consider that it's also connected to E2. So, the formula will be E1 minus E2. So, yung voltage between the two nodes times dt. Alright, I'm sorry. I think may kulang dito. Yan, integral. Then, let's move on. So, kung napapansin nyo, one node will be one equation. So, we have two equations here. So, 0, dahil wala tayong current source dito, is equal to C2 dE2. Again, subscript is very important. Over dt. Plus, itong L2. Ano ba itong, paano yung sa L2? L2 E2 dt. Then, itong resistor na to, E2 over R2. Plus, so, don't be confused kung ano yung element, dapat indicated here. Hindi pwedeng R1 or basta R lang isusulat mo dito because malilito ka sa kung anong element ba yung tinutukoy. Plus, 1 over L1, ito yun. Ito na lang natitirang element na hindi nasusulat. So, this time, instead of E1 minus E2, it will be E2 minus E1 dt. So, this is very important sa electrical system because the direction of the current or the voltage differs between each node or each loop. Alright? So, that's the example for both we'll move on to our next topic.